Hello everyone. In this video clip, I am going to discuss another non-routine question from the chapter Differentiation and Integration. Now, why do I say that it is non-routine? Okay, let's read the question together. Okay, given that the gradient of tangent of two curves are 6 minus 2x and kx minus 9 over 2. If the curves intersect each other at a right angle at the point 2, 4, we have to find the value of k and find another x coordinates and also the equation of each curve. Now to start off, if you have seen my previous differentiation and integration question, you'll notice that I always like to sketch. Okay, now this is just a sketching, so it may not be accurate, but doesn't matter. We just want to sketch and fill in those important information that we have in hand. So over here, we do have the gradient of tangent. That means tangent is the straight line that touches the curve at one point. All right, so for both curve, I have the tangent, and each tangent the question give us the gradient of tangent. So MT1, since I have two curves here, so I label them as MT1, which is 6 minus 2x. And another gradient of tangent, MT2, equals to kx minus 9 over 2. Now, what do I have? Yes, the two curves intersect at one point, that is 2, 4. And the question says that the curves intersect at the right angle. When you see the keyword right angle, the immediate thing that comes to our mind is they are perpendicular to each other. So when they're perpendicular to each other, we know that M1 times M2 equals to -1. That is the concept that we have in mind. When you see the keyword perpendicular, or they say intersect at right angle. Intersect at right angle. Okay, so immediately that comes into our mind, it would be M1 times M2 equals to -1. So remember this. That is how we start. Now, when the question say the curves intersect perpendicularly at 2, 4. So the curve, how do we measure the right angle? So we measure based on the tangent, isn't it? Okay, and since this is a tangent function, so at any point, this gradient of tangent applies. So therefore, we shall use the MT1 times MT2 and equalize it to -1. So let's do it. So part A, okay, we got to substitute 2 for x equals to 2 into MT1 and MT2. So for MT1, we will have 6 minus 2x, yeah? Therefore, we have 6 minus 4, 2. Whereas, okay, MT2 will be k times 2. K times 2 minus 9 over 2. So we have 2k minus 9 over 2. And with that, put them in MT1 times MT2 equals to -1. So 2 times 2k minus 9 over 2 equals to -1. So we have 4k minus 9 equals to -1. Therefore, 4k equals to 8 minus 9. Sorry, -1 plus 9 got 8. So k equals to 2. So we have just found k. All right. Secondly, we have to find the coordinate x of another intersection point. So again, the same concept applies. We just need to take MT1, which is 6 minus 2x. Okay, if we multiply with MT2, which we already found the k, that is 2. So 2x minus 9 over 2, it's the gradient of our tangent, the second tangent. So take the first gradient of tangent times the gradient of the second tangent, 2x minus 9 over 2. That gives us -1. So expand our expression. So we will have 12x minus 27 minus 4x squared plus 9x equals to -1. Okay, next, got to rearrange. So I'm going to move everything on the left towards the right so that my x squared is always having positive number as its coefficient. So I will have 4x squared now. So 12x and 9x is 21. After we bring over to the other side, it will become minus 21x. And then the -27, after we bring to the other side, -1 plus 27, we have plus 26 equals to 0. So next, we have to factorize it. Okay, 26, we have 13 times 2, and then 4 must be here. Or you can use the calculator, get the answer. You will get x equals to 2 or x equals to 13 over 4. Now in the question, x equals to 2 is already given. So the other points, the other coordinate x of another intersection point will be x equals to 13 over 4. So we have found our answer for B. Okay, this is the one given. So this is the one that we want. Okay, now next, part C. Part C, we need to find the equation of each curve. So for empty one, now gradient of tangent basically is dy by dx. All right, so 6 minus 2x. This is for the first curve. So to find y, what we need to do is to move the gradient, the differentiation function across to the other side of our equation. So the function of differentiation, when you reverse it, will become integration. So we got to integrate this. Now the integration of this y is the indefinite integration. So we have to put the plus c at the back. So 6x minus x squared plus c. And how do we find the value of c? We just need to substitute the 0.24 into the equation because the 0.24 is on the curve. So it will satisfy the equation of the curve. So whenever we see y, we replace with 4. Okay, replace 2, 2 squared plus c. So over here, 12 minus 4 plus c, which is 8. Bring over c equals to -4. Therefore, the equation for the first curve will be 6x minus x squared minus 4. And on the other hand, dy by dx equals to 2x minus 9 over 2. So y equals to integrate 2x minus 9 over 2 towards the x. So we will have x squared minus 9 over 2x plus c. And again, substitute 2, 4 into the equation. So we will have 2 squared minus 9 over 2 times 2 plus c. So over here, we will have -5 plus c. Therefore, c equals to 9. So the equation for the curve will be y equals to x squared minus 9 over 2x plus 9. That's it. Okay, this is how we solve this question. So the important thing is whenever the question, give you the keyword like curve or the straight line intersect at right angle or they intersect, they are perpendicular to each other, link with the gradient. So with that, you can solve this question, even though it is very non-routine, but you can solve it because we always go back to the basic concept. So I hope this video clip can help you. I'll see you in the next video clip for more difficult question on HOTS or KBAT. Thank you. I'll see you next time.